Hello viewers. In the previous programs, we have discussed the common network security terms and virtual private networks. So let's start with this program, which is on firewalls. Computer networks is mainly used for information and resource sharing, but Internet has added a new dimension. Internet has opened the floodgates of information. You can access any kind of information over the Internet. Electronic banking, Internet shopping, online transactions give rise to greater security requirements over the Internet. In this program, I will explain to you the firewalls. Firewall is the most important and fundamental security mechanism which can be implemented either by software or a combination of hardware and software. A firewall has a set of rules specifying what traffic to allow or deny passing through it. The information resources that you don't trust can be just blocked by creating block rule in firewall, and that's it. The blocked resources and websites will not be able to communicate with you. In this program, we will start with our discussion with firewall design principles. Then we will discuss what firewall can do, and then we will proceed with firewall types, and we will finish our discussion with some of the firewall configurations. Let us first have a look at firewall design principles. The information and services available over Internet are essential to every organization and every individual user. But information resources and services available over the Internet are not trustworthy. That is, they can be hacked. So we need security mechanism to prevent organization or individuals users from external attacks. Firewall acts as a boundary wall around network or individual computer system which controls the incoming and outgoing traffic. The firewall inspects each and every incoming packet before delivering it to internal system. Firewall works on basis of rules, the inbound and outbound rules. Inbound rules are those which are enforced on incoming packet, and outbound rules are enforced on outgoing traffic. Firewall takes two types of action. These are allow and block. Inbound rules define which information or service can interact with internal systems, and outbound rules determine which information or service can interact with external network. The firewall may be a single computer system or a set of two or more systems that cooperate to perform the firewall function. The figure on the screen represents the concept of firewall. Another figure showing action of firewall as a filter is shown on the screen. To implement firewall, some specific requirements should be satisfied. These are: number one, all traffic from inside to outside and vice versa must pass through the firewall. This is achieved by blocking all access to the local network except via the firewall. Various configurations are possible that we will discuss later in this program. Second requirement is only authorized traffic as defined by the local security policy will be allowed to pass. Third requirement is the firewall itself should be immune to penetration. This implies that a trusted system with a secure operating system should be used as firewall. There are four general techniques that firewalls use to control access and enforce the site's security policy. These are service control, directional control, user control, and behavior control. Let us take up the service control. The service control determines the types of Internet services that can be accessed, inbound or outbound. The firewall may filter traffic on the basis of IP address and TCP port number may provide proxy software that receives and interprets each service request before passing it on, or may host the server software itself, such as a web or mail service. Directional control determines the direction in which particular service request may be initiated and allowed to flow through the firewall. That is, inbound means into the protected system, or outbound means out of the protected system. User control controls access to a service based on user who is attempting to access it. This feature is typically applied to users inside the firewall perimeter, that is, local users. It may also be applied to incoming traffic from external users. The latter requires some form of secure authentication technology, such as is provided in IPsec. Behavior control controls how particular services are used. For example, the firewall may filter email to eliminate spam, or it may enable external access to only a portion of the information on a local web server. Before proceeding to the details of firewall types and configurations, it is best to summarize what one can expect from a firewall. The following capabilities are within the scope of a firewall. A firewall defines a single choke point that keeps unauthorized user out of the protected network, prohibits potentially vulnerable services from entering or leaving the network, and provides protection from various kinds of IP spoofing and routing attacks. A firewall provides a location for monitoring security related events. Audits and alarms can be implemented on the firewall system. A firewall is a convenient platform for several internet functions that are not security related. These include a network address translator, which maps local addresses to internet addresses, and a network management function that audits or logs internet usage. A firewall can serve as the platform for IPsec. Using the tunnel mode capability, the firewall can be used to implement virtual private networks. Firewalls can be classified based upon the process followed by them for allowing or denying a packet into or out of the network. According to this classification, firewalls may be classified as filters, address translation, which include both source network address translation, that is SNAT, and destination network address translation, that is DNAT, and mangle. Filters are the kind of firewalls which allows a packet or rejects a packet based upon certain criteria, like packets related to a particular service, etc. Source network address translation and destination network address translation is used when it is necessary to route a packet destined for a particular IP address to some other IP address, or when source address is to be changed to avail a particular kind of service from a server. In former case, when destination address is changed by firewall, process is called DNAT, that is destination network address translation. In the later case, when source address of the packet is to be modified by firewall to avail a service, the process is called SNAT, that is source network address translation. Mangle firewall implies that some particular type of packets are to be given priority on rest of the traffic. This is normally done to maintain quality of service. Firewalls can also be classified based upon the criteria used by them to allow or deny an incoming or outgoing packet. According to this classification, there are three common types of firewalls. These are packet filters, application level gateways, and circuit level gateways. We will examine each of these in turn. A packet filtering firewall mechanism can be implemented using router. Router applies a set of rules to each incoming and outgoing IP packet and then forwards or discards the packet. The router is typically configured to filter packets going in both directions. Filtering rules are based on information contained in a network packet, which includes source IP address, that is the IP address of the system that originated the IP packet, destination IP address, that is the IP address of the system the IP packet is trying to reach, source and destination transport level address, that is the transport level port number, which defines applications such as SNMP or Telnet, IP protocol field, which defines the transport protocol interface. For a router with 3 or more ports, which interface of the router the packet came from or which interface of the router the packet is destined for. The packet filter is typically set up as a list of rules based on the matches to the fields in the IP or TCP header. If there is a match to one of the rules, that rule is invoked or fired to determine whether to forward or discard the packet. If there is no match to any rule, then a default action is taken. Two default policies are possible. One is default is equal to discard. According to this policy, if something is not explicitly permitted, it is discarded. Second is default is equal to forward. According to this policy, if something is not explicitly prohibited, it is forwarded. The default discard policy is more conservative. Initially, everything is blocked and the services must be added on a case-by-case basis. This policy is more visible to users who are more likely to see the firewall as a hindrance. The default forward policy increases ease of use for end users but provides reduced security. The security administrator must, in a sense, react to each new security threat as it becomes known. One advantage of a packet filtering router is its simplicity. Also, packet filters typically are transparent to users and are very fast. Following are some weaknesses of packet filter firewalls. Now, because packet filter firewalls do not examine upper layer data, they cannot prevent attacks that employ application specific vulnerabilities or functions. For example, a packet filter firewall cannot block specific application commands. If a packet filter firewall allows a given application, all functions available within that application will be permitted. Because of the limited information available to the firewall, the logging functionality present in the packet filter firewall is limited. Packet filter logs normally contain the same information used to make access control decision, that is source address, destination address and traffic type. Most packet filter firewalls do not support advanced user authentication schemes. Once again, this limitation is mostly due to the lack of upper layer functionality by the firewall. They are generally vulnerable to attacks and exploits that take advantage of problems within the TCP/IP specification and protocol stack such as network layer address spoofing. Spoofing attacks are generally employed by intruders to bypass the security controls implemented in a firewall platform. Finally, due to the small number of variables used in access control decision, packet filter firewalls are susceptible to security breaches caused by improper configurations. In other words, it is easy to accidentally configure a packet filter firewall to allow traffic types, sources and destination that should be denied based on an organization's information security policy. Now, second type of firewall is application level gateway. An application level gateway, also called proxy server, acts as a relay of application level traffic. The user contacts the gateway using a TCP/IP application such as Telnet or FTP, and the gateway asks the user for the name of the remote hosts to be accessed. When the user responds and provides a valid user ID and authentication information, the gateway contacts the application on the remote host and relays TCP segment containing the application data between the two endpoints. If the gateway does not implement the proxy code for a specific application, the service is not supported and cannot be forwarded across the firewall. Further, the gateway can be configured to support only specific features of an application that the network administrator consider acceptable while denying all other features. Application level gateways tend to be more secure than packet filters. Rather than trying to deal with the numerous possible combinations that are to be allowed and forbidden at the TCP and IP level, the application level gateway need only scrutinize a few allowable applications. In addition, it is easy to log and audit all incoming traffic at the application level. A prime disadvantage of this type of gateway is the additional processing overhead on each connection. In effect, there are two spliced connections between the end users with the gateway at the splice point, and the gateway must examine and forward all traffic in both directions. The figure shown on the screen represents the concept of application level gateway. There is one connection from inside host to application level gateway, and another connection is from application level gateway to the outside host. Now the gateway has to examine the traffic in both directions as shown in figure as per the rules framed. A third type of firewall is the circuit level gateway. This can be a standalone system or it can be a specialized function performed by an application level gateway for certain application. A circuit level gateway does not permit an end-to-end TCP connection. Rather, a gateway sets up two TCP connections, one between itself and a TCP user on an inner host and one between itself and a TCP user on an outside host. Once the two connections are established, the gateway typically relays TCP segments from one connection to the other without examining the contents. The security function consists of determining which connections will be allowed. The figure on the screen represents the concept of circuit level gateway. In this figure, it can be seen that there are multiple incoming lines and multiple outgoing lines available in circuit level gateway. Allowed combinations of input to output lines are programmed into circuit level gateway. A typical use of circuit level gateways is a situation in which the system administrator trusts the internal users. The gateway can be configured to support application level or proxy service on inbound connections and circuit level functions for outbound connections. In this configuration, the gateway can incur the processing overhead of examining incoming application data for forbidden functions, but does not incur that overhead on outgoing data. So, in this session, we have discussed the firewall as security mechanism for protecting internal system from external untrusted network. Firewall works on rules. On the basis of rules, firewall decide which internal network service and information can interact with the external network and which external service and information can interact with internal network. We also discussed different types of firewalls and advantages and disadvantages of each type of firewall. I hope this program has added to your knowledge regarding the covered topics. Thank you.